All right, we're in chapter 4 on analyzing change. This is the applications of derivatives. Now we're in section 4.5 on marginal analysis. So there's marginal cost, marginal revenue, and marginal profit. So if we have X, some number of units of a product produced in some time interval, then we have the total cost we know is just, we can label it as C of X. Now the marginal cost is going to be the derivative of C of X. It's going to be C prime of X. Now, if we have total revenue, we usually label that as R of X, and our marginal revenue is going to be R prime of X, the derivative of our R. Now, total profit, that's usually P of X, which is just our R of X, our revenue, minus our cost. And so then our marginal profit is basically just our derivative of P, or what we can do is we can take the derivative of R minus the derivative of the cost. And so basically it's your marginal revenue minus your marginal cost, and that will give you your marginal profit. Now, the marginal cost or revenue or profit is really that instantaneous rate of change of cost or the revenue or the profit, depending on which one we're looking at, relative to production at a given production level. Okay. Now, the key thing here is C of X, or our cost function, it represents the total cost of producing X items. It doesn't represent the cost of a single item. So that's a key thing to know. So, if we have C of 200, that's the cost of producing those 200 items, not the cost of producing that 200th item. So what usually we need to do is we need to figure out the total cost of producing. If we want to find the cost of one item, we have to find the cost of producing X plus 1 items, which is going to be our C of X plus 1. We have to find the total cost of producing X items, and then we subtract them to find the exact cost of producing that X plus 1 or X plus first item, okay? And so we're just going to take C of X plus 1 minus C of X, and that's going to give us the cost of producing that X plus first item. Now, the marginal cost versus the exact cost. If C of X is the total cost of producing X items, then the marginal cost function approximates the exact cost of producing X plus first item. So what we can say is our marginal cost, our derivative of C of X, is going to be approximately our cost of X plus 1 minus C of X, which is the exact cost of that X plus first item. Now this works similarly for total revenue and total profit. So we can use the revenue or the profit functions in here, and it behaves the same way as the cost function, okay? Now, I'll kind of put this in more perspective with how the book is going. In economics, the marginal cost is defined as the cost incurred to produce one additional unit. And the marginal revenue is defined as the revenue realized from the sale of one additional unit. So for continuous cost and revenue functions, C and R, with respect to Q units produced and sold, our derivative of either the C or the R with respect to Q gives our marginal cost or marginal revenue of producing that Q plus first item. Okay, so that's kind of the key. And so that's how we can get our uh, marginal cost or marginal revenue, is by taking the derivative. Now, the profit maximization rule basically states a margin, or the profit is maximized when the marginal cost is equal to the marginal revenue. So basically, we have our C prime of whatever X or Q or whatever is equal to our revenue derivative as well. So when those two are equal, profit is going to be maximized. Now this rule applies when costs and revenues for a quantity can be considered to occur at the same time. So the proper analysis must be made, because an equality of marginal cost and marginal revenue may create sometimes a minimum profit, not a maximum. So you kind of really have to look at the curves and see where it is. And so it's not always going to be a maximum profit. Sometimes it's going to create a minimum. So we need to look at our graphs to kind of see that one. And this is kind of an explanation. So the profit maximization rule indicates that the profit is at a relative optimal point where the derivative of the profit is zero. So when our derivative of the profit is zero, our derivative of our is going to be subtracting the derivative of C, that's going to be 0. So then we can set those two equal to each other, and that's going to result in a minimum profit instead of a maximum profit. That's a possibility. So not always going to be the case, but sometimes it is. And so that's why, when we get that profit function, it's best to graph it to choose the optimal point. Otherwise, we can get a point where we get that minimum instead of a maximum. Okay. Now, what is the marginal product? Well, the production function Q gives a quantity of an output that can be produced by a given amount of input. So the possible production factors, input quantities that we can do for a Q, we can have labor, we can have capital expenditure, and we can have natural resources, state of technology, and so on. So depending on which one of these we choose, it can change our production function Q. Now, only one of the production factors is allowed to vary while all the other input quantities are going to be held constant. So that's going to be the key. So the marginal product refers to the change in the production level resulting from one additional unit of the variable production factor. So one additional labor, one additional capital expenditure, one additional natural resource, or whatever. And so an example or two of this is kind of given in the book. And so we have this Honda plant. It manufactures small automobiles, has a current labor force of 2018 associates. Okay, so there's that many employees working on the assembly line. Now, production function is represented by Q automobiles, where L associates, out of 2018, is the size of our labor force. Now, if we have Q of all 2018, we're going to produce 119,200 automobiles. The marginal product with respect to labor is going to be Q prime of 2018, our derivative of that. And basically what we find out is we're getting 60 automobiles per associate. Okay. So if we increase the number of associates to 2019, so we go from 2018 to 2019, that means we're going to increase it by 60 automobiles is going to be our um, product function is going to change. And so it's going to change by 60. So we're going to add 60 to this. And so we're going to get out 119,216 or 260 automobiles annually. Okay, so we're just adding those 60 by each person producing one more. If we add one more person to the thing, we're going to get 60 more automobiles. Now, another example is if we have capital investment of K million dollars, then the notation Q of K automobiles represents the output of a production function for that many in $1 million invested. So if our current production is Q of 200 million and we get 119,200 automobiles out, well, if the marginal product with respect to the capital is, again, we're taking our derivative of our Q function, and if we get 600 automobiles per $1 million invested, what happens is then if we increase this to 201, that means we're going to increase by 600 automobiles per million. So we're going to add 600 automobiles to our original value here. And so we're going to end up with 119,800 because each $1 million additionally invested is going to give us 600 automobiles. So we'd add that to here and get our 800 automobiles instead of that 200 on the end. So we're still going to have 119,000, now 800. All right, so we'll stop there and then we'll come back with examples on how this all ties into problems.